Hi, my name is Aditya. I am the CEO of Automatski. Today, I'm going to be showing you our product suite called Communicare, which is a telecom use case product suite built on top of the uh, hybrid graph solver from Automatski. Now, Automatski is a full stack quantum computing vendor. It makes quantum annealers and gate based quantum computers. Its quantum annealers can solve problems up to 500 million qubits or Boolean variables, and its gate-based quantum computers can solve problems with hundreds of logical qubits and millions of gates. We are not dependent on any other company for quantum computing technology. Automatsky works on problems like optimization, vehicle routing problem, drug discovery, chemistry and materials, finance, CFD, quantum AI, cryptography, and nuclear fusion. But we had a consistent demand from prospective telecom customers for telecom use cases. And that is why we are launching Communicare. Now, telecommunications is a domain where graph coloring appears in a lot of problems because almost 50% of the problems in telecommunications can be modeled as conflict graphs, where vertices are devices, towers, links, channels, users, time slots, routes, etc. And edges are constraints which make sure that you cannot use the same resource simultaneously or adjacently. Colors are things like frequencies, channels, time slots, codes, routes, wavelengths, or compute resources. Now we have 15 use cases before us. These start with frequency and spectrum allocation, where nearby towers and cells can interfere if they use the same frequency. There is cellular tower optimization, where you have to optimize the tower placement, sectorization, and channel assignment. We have Wi-Fi channel assignment and Wi-Fi access points, which interfere on overlapping channels. There is TDMA, time slot scheduling, where devices sharing the same medium cannot transmit simultaneously, so they have to multiplex in time. Optical network wavelength assignment, where light path sharing fiber links cannot use the same wavelength because you are going on the optical fiber and one wavelength can carry only one signal. You have radio resource management in 5G and 6G, where physical resource blocks, beams, etc. need to be scheduled and managed for interference and allocation. There is device to device communication, where nearby devices communicating directly interfere with each other, usually in mesh networks or uh, edge devices. There is cognitive radio networks, where secondary users must opportunistically use unused spectrum. That is for optimization of spectrum utilization, etc. Satellite communication scheduling, where satellite beams and uplinks interfere. Network routing and link scheduling, where certain links cannot be active simultaneously due to interference. Self-organizing networks, where you need to automatically assign channels and relationship with neighbors. Load balance and coordinate interference. Beam forming and massive MIMO, where certain beams interfere spatially. Network slicing in 5G and 6G, where slices compete for shared radio resources. Edge computing resource allocation, where tasks competing for compute and network resources on the edge. Interference coordination, where we have to coordinate neighboring cells to reduce interference. So I'll show you what we have. We have developed all these five use cases, and uh, these are all available in the SDK for the customers to get started right away. As you can see, there are 15 use cases here, exactly the ones that I mentioned in the presentation. And you can simply run them by saying Python and the problem name, and you can scale up to hundreds of thousands of nodes. So you can see that uh, the frequency spectrum allocation between the railway small cell, airport macro cell, suburban macro cell has been allocated. Cell tower optimization. And cell towers have been optimized to use different wavelengths so that they don't interfere. Wi-Fi channel assignment similarly, and you can assign Wi-Fi channels to access points. So we are ready, and we are addressing 15 use cases in telecom using quantum annealers and graph coloring hybrid solvers built over our quantum annealers, which can solve problems up to 500 million Boolean variables. So you can actually solve production scale problems across the country or continents. Thank you very much. That's all we had for you today. Let us know how we can help.